So we're here to talk through this challenging Nurikabe from Tapio Saarinen. It went by the title Big Twister because of its comparison to an earlier puzzle in the week, but you can also see another theme that Tapio had embedded in is the use of the digits 1 through 5 only in the clues, and even these big clues here, we've avoided the space of 6, 7, 8, 9, and 0. And this is a quite challenging Nurikabe. It requires two kinds of rules or thinking that you don't encounter too often with this style, which is one reason I thought this was a good puzzle to highlight on the Saturday, but it's also one of the hardest puzzles we've posted, so I think some solvers will certainly run into challenges after shading some of these cells. One of the things you need to do quite often with the harder Nurikabe puzzles is to think about places where islands can't easily reach. And in this puzzle, I'm going to start by highlighting this 2x2 block. It is the case that none of these low-digit islands near it can ever put a cell into this space. So there must be some island that connects out to this. It could be the 12 or the 13, but there needs to be an island that reaches in to get to this space. And when we sort of lightly sketch this kind of line, let's just sort of say something like this, what we need to do is do a think ahead of how a path can exist to get over to this space. For instance, one of the easiest kinds of spots to think about is a cell like this. Is it possible that this is an island cell that's part of the path that connects from here to the number? Well, if this is an island cell, the 5 has no room at all to exist, that it has essentially one more cell it can take, and so this is an unusable cell. And consequently, the only path that gets you to a connection to the right has to come through this cell that we've now sort of blocked off this channel. And we can think further about that this 5 still is pretty limited in how it can connect. That one thing you may recognize is that for it to have room here, the path still needs to sweep around it, but it's unlikely, for instance, the 5 can get all the way down to here. So let's look at this cell, and let's say, is it possible that this can be part of an island? And one thing that may be useful to do at this time, this is something that's set up by the tight constellation of clues in the center, is to actually think about essentially a deduction that's tied to getting some ocean out from this center region. And so I will start it, I guess, maybe this sort of way, is to think about this 4 and can it connect 2 cells to the left and then to the top. And this forms a domino cascade in some sense, that it forces all of the adjacent islands to also come up and over and close off all of the exits for this center plus shape right now. And it's the case, you can see this from any of the clues, but it's effectively the case that the clues can't sweep up and block an edge, that the 5 has to come down, this 4 has to come down at least once, this 5 has to come over once, this 5 has to come up, and it can't do too much more than that. But this starting constellation is a requirement for this puzzle to have an answer. And now we have a case that from the bottom, this clue, which has 1, 2, 3, 4 cells in this row, is going to take at least one cell up here, which means that for this island path, if the island path, if this is an ocean, the island path using all of those cells to get across would now collide with this island, and that's just not possible. So knowing that we need to get through this group, this second cell must be an island, and in particular, it's not part of the 5 above, and so you can actually now make a fair number of deductions about the path from the results of these 2 cells. We can specifically make this way for the large number to link. Those are going to connect somehow. We're now at a stage where we can think about which of the 12 or 13 connect to it, and again, this path is going to join to the number, so if it joined to the 12, this set of ocean would be trapped, and so it must be the case that the 13 is the clue that's coming over to make this connection. So we can start to shade the 12 over to the right. The ocean can't escape through this channel because of the path eventually made, so the ocean has to escape through that cell to the right. This is sort of the forward-thinking challenge again. We still need one island cell from this 5, so we've now actually deduced by trying to force the path in that it's this shape that comes out. This ocean is going to essentially, we're looking at for connectivity all the time. For instance, this top ocean has to come down and around. This island needs to extend, so the oceans nearby have to continue to extend. Get somewhere like this. And the 13 right now is using 11 cells, so it needs to grab 2 more. That takes it over to there. The ocean around it is easier to shade from that point. This 2 has to go one of 2 directions, but in either direction it knocks off that ocean cell. And what you need to sort of, again, this is a think ahead sort of moment. If the 2 comes to the left, it's going to pin the 4 down and in such a way strand all of the top ocean that for the ocean to get out, the 2 has to be somewhat well behaved and come down. And similarly, can the 4 ever use this cell as part of its island? Well, that would pin off all of the ocean around it. So the 4 can't get to this cell. Can the 4 get to this cell? Well, it's going to now put ocean all the way up here, so this is unusable. Collectively, you get that island and this connection. And that's all we can do on the left side for now, so let's focus back on the right side. We've placed 9 cells for this island. I'd like to convince you that this cell must be used. If that cell is not used by this island, this would be 10, 11, and 12, but this ocean needs to get out, so that cell must be an island. There's a separate kind of deduction, which is that this cell must be ocean, but that's this group getting out of the grid. It has just one way out. We now have an ocean that needs to connect. If this is 10, 11, it must use that cell, so the ocean must come down. This 3 island no longer has many choices, so we'll put in what's required. We're now still at 11 here, so this cell or that cell will be the 12th for the island. The result is this is going to get shaded. This 5 clue doesn't have a lot of space left for it, so it must come to the right. And what we see is actually 3 cells left that it can take, or maybe these 2 that it can take. What's important to recognize is that, let's see if we can do this here. This first option, like this, is going to cause a problem where you need another island cell in this block of 2 and another island cell in this block of 2. And there's only one more cell from the 11 that can come out. So what the 5 actually has is just a total of 3 potential cells, 1, 2, 3 that can use to get 2 more. And if it used both of these bottom cells, it would now strand this ocean here. So consequently, it must come up, and it's going to take one or the other of the remaining cells below it, but we can get to this state. The 4 needs to use at least those 2 cells coming down. We get to another kind of 2 by 2 consideration here. This needs to have an island in some of its cells, at least one of these cells. You can ask yourself, does it come from the 4? Well, if not, it's got to come from some other island. That island is going to have to be the 13, which it's going to be pretty stranded. Not give room for the 12, so it would have to be from the 12. And if it were from the 12, the remaining island from the 4, whichever it is going to pin off the connection of these ocean cells with any other ocean cell. And so a little bit of pre-thinking of getting the ocean connected will tell you that the requirement to fill the 2 by 2 block in this corner is going to use the 4 and get to a spot like this. And this, at least with my solving, was the hardest sticking point for the puzzle, and it has to do with figuring out, again, if we look to the right, this whole ocean block needs to connect through to the left side at the same time we satisfy this rather large island. Now there are two ways the cells could go, and one is that the ocean can come to the top of this island, and what would result from the ocean coming to the top of the 12, the 5 is going to come down, the 2 is going to come down, the ocean is going to continue like this. The 12 now doesn't have enough room to fill itself up, but there are 11 spots for it, and if we mark off what would have to be ocean, we'll never place 12 island cells and still have the ocean fully connected. So it's not the case that the ocean comes to the top and around the 12. The ocean has to come beneath the 12. And this gives a deduction which should be more familiar than I think solvers find it, which is that you now can't have any other island touching this bottom group, that the 12 is going to come some way like this, but for these cells, which can't be reached by any other island, the 13 can't come in and leave enough room, that these cells, this is sort of the path the ocean's going to take, and there's going to be an island here, but there's going to be ocean, sort of mark however you want, an island, mark however you want, going around like this. And so what you want to do is try to specifically count for this 12 and look at this cell here and say, is this required to be an island? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the ocean's still coming around. This certainly is an island cell. And that means that if this ocean is going to connect to the left side of the puzzle, the one beneath it has to be an ocean. And the ocean would have to connect sort of like this. The 3 island here needs to fill some space, so at least it takes that cell, which means an ocean at least sits over it, and so this island actually looks like that. That finally tells us what these groups up here look like, which is something like this. Fill that in for the moment. This ocean group here is not going to be escaping through this island. It's going to come out to the left. If we do a careful count now, we see 6, 7, 8, 9, 10, 11. It's going to at least require that cell. We put in the ocean into it. What we have with this 4 is one potential island here, but it will at least take this cell. So we can shade that in. Now what you want to ask is, again, sort of with the count, if this now is at 11, it's going to take this cell. If our whole concept was that the ocean would be connecting through the bottom, the ocean has to still be connected. Now we've blocked its path to the top. That this general sense of connectivity is still slowly guiding all of the island placements we have. What we sort of did was find this channel in the middle, just like there was this channel at the top at the start of the puzzle. We found this channel in the middle of this path that the ocean would wrap in, another island would sit around, and so we finally placed the 12 island cells there. And it was a bit of work to get them, but I think if you ever manage to do it and fully logically, it's quite rewarding to recognize how those all fit. And it's not that we're through the woods yet, there's still a little bit of a tricky conclusion. Let's get those cells marked. There will be an island, at least in the top cell here. The ocean still to be connected, it's going to come there. You should recognize that there's some connection we don't know anymore that gets to the 13, which means that the ocean is going to have to come around the 13. At least take that cell. You can ask yourself now, if these two cells, one of them must be an island, is it possible that there's an island here in the bottom one? Well, that would have to come from the 13. That would again block off the ocean's path, so the island cell has to be from above. We get a 3 with one of the 2 cells remaining. This is a case if you had something like this. If the island were on the left, you now have still a need to connect this ocean to this ocean on the right and this ocean on the left. But how is the 13 going to come up here? And for instance, if that connects this way, it's going to strand off the ocean to the right. If it connects this way, this ocean itself is going to be stranded. The tricky step to see, and you may just do this by forcing as large a group for the 13 as you can, but logically you can require that the island's on the right so that there is a path for all of the ocean cells around it to connect up. It's going to be this, and if we do a count, we'll see we have exactly 13 cells left, and we've managed to solve this rather tricky puzzle. It is quite a big twister in the sense of getting all the logic, but sort of the unique thinking around the center, where we looked at closing off these groups, and then the unique path logic with this 13 clue and this 12 clue in the bottom. Both sort of real standouts that make this a challenge, but also quite a reward to solve. I hope you learned a little bit about more involved Nurikabe steps with this talk through, and we'll see you again in the future.